Hello guys, welcome back to our channel. The paper we are solving today is IGCSE Physics October-November 2023 and this is the paper number 22. Now, starting with the first question, which quantity is a scalar quantity? We know that scalar quantity is the one which does not require direction. Direction is not required. Now, acceleration is a vector quantity, it needs direction, so it is not the answer. Force is also a vector quantity. Time doesn't require any direction. It is same. If you live in Delhi, if you live in any part of the world, the time is same. Although the time zones differ, that is true. But if you're in a specific location, the time doesn't depend upon direction. If you're going at east direction, the time is not different. It doesn't work like that. Time does not depend upon direction. It's a scalar quantity. Velocity, again, it depends upon direction. So velocity is a vector quantity. Now, a student measures the average speed of a cyclist in a race. We know that average speed is equals to total distance covered by total time. Let's say you're going from point X to point Y. Now there is you A, there is your friend B. You're going continuously and you cover X to Y. But your friend, the lazy one, he decides to watch anime in between. Now your friend is watching anime in between. So will that time be counted? Obviously, the time will be counted. Since you are going from X to Y, the total distance is fixed, but the time taken by you is variable. So everything will be counted. So total time will be counted, total distance will be counted. Total time taken to complete the race, correct. The time taken for the cyclist to reach a higher speed. Why does this matter? The total time will be required for highest or lower speed or medium speed. It's not necessary. Total time taken to complete the circuit, total distance traveled by the cyclist, yes. At a higher speed, no. Is it a must that you always need to travel at higher speed? No. The total time taken to complete the race and the total distance traveled by the cyclist looks more sensible. So answer is C. Now, question number 3. The diagram shows a series of images of a moving object taken at regular intervals. The object is moving from left to right. And it is at regular intervals, means the time taken between all of them is same. And you can see initially the distance is also same. So we can say speed is constant here. It is moving at the same speed. But then you start to notice distance is increasing. Now even more, and it is continuously increasing. So we can say initially there is constant speed, but then there is acceleration. So object travels at constant speed and then accelerates. Answer should be C. Alright, now question number 4. This is one of the good questions. Good question in terms of concept, but is it difficult? I don't think so. See, a plastic ball has a mass this much and volume this much. There is a crack in the ball's surface. Alright, the ball is placed in a bath of water. Water leaks into the ball without changing the volume of the ball. So the volume is same, but the water is leaking into the ball, means the mass is changing. And eventually the ball sinks. Density of water is given. Which mass of water has entered the ball when the top of the ball is first level with the water surface? So it is trying to say when ball is here nearly and water is here nearly. So when it is nearly like a floating condition, and we know that during floating condition, density should be the same. So we can say density of water is equals to density of ball. Density of water is 1 grams per centimeter cube. Density of ball must be mass of ball divided by volume of ball, right? The point to be noted here is that it is floating when the water has already gotten inside the ball. So the mass of the ball here will be ball's mass plus water's mass, right? You need to keep this in mind. Now, the mass of ball is equals to 1 into 20. So the mass of ball is coming out to be 20 grams. Now just think about it. What I did is I transposed VB to the left hand side. VB times 1 is VB only. And the volume of ball was 20. So mass of ball is also coming out to be 20 grams. And initially when water was not flowing inside, what was the mass of ball? 4 grams. Now the combined mass of ball and water is 20 grams. So what should be the answer? 16 grams. Answer is B. It's a simple question, but you need to think it through thoroughly. It doesn't require too much maths. It's a physics question, but you need to think carefully. Initially, the mass was 4 grams only. When it is floating, the density of water is the density of ball. Density of water is 1. Mass of ball, I'm keeping as mass of ball only. And volume of ball, transpose it there. Mass of ball comes out to be 20 grams. And initially, the mass of ball was 4. Now the mass is 20. So, how much water is added? 16 grams. All right. Question number 5. The satellite orbits Earth at constant speed in a circular orbit. All right. Now, a lot of the students will end up making the mistake that, oh, constant speed is there. It means net force will be 0. Resultant force will not be there. So, they will directly pick the answer as A and they will be happy. But the point to be noted here is, even if it is constant speed, if the object is revolving in a circular motion, you should question yourself what is making it revolve in a circular motion. It is gravitational field from the Earth. In this case, Earth is the center, satellite is rotating like this, revolving like this. All right. So the gravitational force is the resultant force in this case. Remember, centripetal force is the resultant force. So resultant force is towards the center of the Earth. Answer should be B, towards the Earth. That is the correct answer. All right. So the answer is B. Wherever it mentions that the constant speed is there, it doesn't mean net force is 0. Sometimes it might mean that circular motion is there, then the resultant force is towards the center. All right. Now, question number 6. The diagram shows 4 identical objects. Each object is acted on by only the forces shown. Which diagram shows the object in equilibrium? See, for equilibrium, net force need to be 0 and net moment needs to be 0. Is the net force 0 here? It is. But is the net moment 0? Think about it. Let's take this as the pivot. So this will have this much distance, this will have this much distance. It doesn't appear that the net moment will be 0. It will rotate some way, right? Think about it. So A is not the answer. And B looks little correct, but let's see. B according to moments is correct, but the net force is not 0. Total upwards is 20, total downwards is 10. So this is not an equilibrium, right? This 10 Newton will cancel this 10 Newton, but there is nothing to cancel this. This is also not an equilibrium. But now option D, this is an equilibrium. The net upward force is equal to net downward force, and the moment of force is also 0 here. Alright, so the answer should be D. Now, a resultant force accelerates a car along a from rest to V time. Okay. Alright, so it is going from U0 to V in T time. Right. Which pair of relationship for this situation is correct? So this is momentum into time is mv, force is equals to power into time. Sorry, momentum into time. So this is telling me that we have to apply the relations of impulse here. So impulse is mv minus mu, and that is also equals to force into time. Right? So force into time should be equal to momentum, change of momentum. Force into time should be equal to change of momentum, right? So we can call this as delta P is force into time. See, it is giving it momentum P. So instead of delta P, let's keep it as only P only. So F into T is equals to P. This is wrong. This is wrong. This is correct. Just by looking at this, you could answer. The answer is C. Momentum is mass into velocity, but force into time is also momentum. So answer should be C. Alright, this is a formula based question. Now, the diagram shows part of a roller coaster ride with the car at different positions. The car runs freely down from position X to position Y. So it is at some height, it definitely will have some gravitational potential energy. And as it goes down, the kinetic energy increases. What happens to the energy in the kinetic store and the gravitational potential store of the car as it moves from position X to Y? Energy in the kinetic store. What do you think? As it is going down, the kinetic energy increases. So answer should be out of C and D. And energy in the gravitational potential store must decrease because the height is decreasing. So the answer should be C. Very simple. Now, question number 9. A box is at rest at the top of a rough surface. The box slides down the slope. The weight of the box is this much. The slope is 4 meter, this much height. The box does 10 joules of work against friction as it slides down the slope. Now, the simplest way to solve this kind of question is just think about it. At this point, you will have some energy x, and at this point, you will have some energy y. And according to our basic knowledge, we know that if it is just starting at rest, so at x, it will only have Gp, gravitational potential energy, and at y, gravitational potential energy will be 0, kinetic energy will be high, maximum, right? And basically, in the general questions we do, Gp is converting to kinetic energy. But in this case, they're mentioning the box does this much work against friction. What it means is the box is utilizing some of its energy. How much? 10 joules. The box is utilizing 10 joules out of its total energy to move downwards. It simply means out of the gravitational potential energy you have, 10 joules has been utilized. So 10 joules you will subtract and the remaining will be converting to kinetic energy. It's just like saying at the top you had 100 joules of energy, at the bottom you had 90 joules of energy. So where is the 10 joules gone? 10 joules is gone against friction, work done against friction. So in the same way, I'm saying initially you had some energy x, out of which you had to utilize 10 joules, and then the remaining got converted to kinetic energy. All right. And if you understand this, then the question is already done. We just need to do the basic maths now. All right. I will do it for you. Give me 1 minute. So we're saying the total energy you had at x in form of Gp, you subtract 10 from it and you will get the remaining kinetic energy. What is Gp? It is m into g into h minus 10 is equals to half into m into v square. Do we know mass? No, but the weight is given. So 20 over 9.8, you'll get the answer to be 2.04 kg. Alright. So m is 2.04, g is 9.8, height is how much? 2 minus 10 is equals to half into 2.04 into v square. Now let's just solve this quickly. 2.04 times 9.8 times 2 is equals to 39.98 minus 10. So this is coming out to be 29.9, let's say. And then times 2 divided by 2.04 is equals to v square. So times 2 divided by 2.04, it is coming out to be 29 point something is equals to v square. Now you can tell me yourself, 6 square is 36. This is not possible, this is not possible. Answer should be A. This is not a very difficult question. What you need to understand is, generally we have been used to doing Gpe is equals to kinetic energy. In most cases, we simply do that mgh is converting to half mv square. This is just a better form of it, that initially you had mgh, out of which you have utilized. The box does this energy, it is utilizing. So out of mgh, 10 joules was utilized and then the remaining got converted to kinetic energy. So this is what I have done and we got the answer as 5.4, which is the correct answer. Alright, now moving on to the next question. An electric car is charged overnight in this much time, this much joules is transferred. What is the power? So we know that power is equals to energy over time, right? What is the energy? 180 megajoules. Remember, capital M is mega, which is 10 to the power 6. And time is 8 times 60 minutes and then 60 seconds. 1 hour contains 3600 seconds. So you will multiply 8 with 3600. Now, because watts is always with respect to time and it is always in seconds. Now, when you do the maths, 180 divided by 8 divided by 3600. So it is coming out to be 6.25 something. Answer should be A. You can check your calculator. The answer will be A. All right. Now, question number 11. An object is at a depth h below the surface of liquid. The pressure due to the liquid at this depth is P. The gravitational field strength is this. All right. So we know that pressure is equals to rho gh. They are asking you what is rho. So rho will be pressure over gh. Pressure over gh. This answer is D. It's just a simple substitution question. You have to just rearrange. Now, question number 12. Brownian motion is the random motion of particles. In which states Brownian motion is observed? Is it observed in solids? I don't think so. It is observed in liquid and gases only. So what is that option? Liquid and gases only, option number B. The volume of a fixed mass of gas is varied. The temperature remains constant. From this, we get to know that they're talking about Boyle's law, which says that PV is equals to constant and pressure is inversely proportional to volume. All right. Now see, if the graph was for pressure and volume only, then it would have been like this, right? But this is pressure volume. This is incorrect. This is pressure volume. This is also incorrect. This is pressure with respect to 1 by volume. Now, just think about it. You're saying that the pressure volume graph is not a direct relation graph. See, pressure is inversely proportional to volume. Look at the terminology I'm using. Pressure is inversely proportional to volume, but it is directly proportional to 1 over volume. Just think about it. If it is inversely proportional to volume, then it should be directly proportional to 1 over volume, right? So pressure and 1 over volume graph is directly a straight line. You can also check your notes. I'm sure your school teachers must have taught you this as well. So it will be a direct relation. All right. Now, liquid evaporates from a beaker. What happens to the temperature of the remaining liquid? See, when evaporation happens, evaporation causes cooling. Just think about it. The particles which are evaporating, these are the ones with more energy. So with more energy, they are escaping the surface. Now you're left with less energy. So the temperature will decrease. So C and D are out. Temperature will definitely decrease. And how does this temperature change affect the rate of evaporation? See, just simple. If the energy is decreasing, overall temperature is decreasing, so the rate of evaporation will also decrease. So the answer should be A. The thermal energy is supplied to an object of mass m which does not change its state, but there is only temperature difference, temperature changing. So they're talking about specific heat capacity. We know that energy is equals to mass into specific heat capacity into change of temperature, right? What is the specific heat capacity of object? You just rearrange it, you will get energy over m into delta T. In this case, they're calling energy as delta E. So write delta E by m delta T. This should be your answer. Delta E by m delta T. Answer is A. Very simple question. Question 16. A room is heated by a radiator. The diagrams X and Y show two possible circulations. So they're talking about convection here. And we know that wherever radiator is present, there hot air will be present. And hot air has less density. So it goes up. Hot air goes up. In this case, they are saying hot air goes down and goes towards the right. Wrong. Diagram Y is wrong. Any option mentioning diagram Y, that is already wrong. Hot air always goes up because it is less dense. Alright, so diagram X is correct, but what is the reason? Air density decreases when air is heated. This is true. Hot air, the particles are far away, so the density is less. Answer should be A. Very simple. Question 17. A student writes down some facts about transverse waves. Wave 1 has a frequency f and a velocity v. Wave 2 has 4 times the frequency and wave 1 and is traveling at the speed velocity of 2v. What is the wavelength of wave 2 in terms of f and v? Now, these kind of questions are meant to be simple, but they're trying to trick you, let's say. And a lot of students often make mistakes in this. What I recommend is that make two different equations. For wave 1, we know that v equals to f lambda, right? And so lambda is equals to v over f. So this is for your wave 1. Now for your wave 2, they're saying that wave 2 has 4 times the frequency of wave 1. So if I say that frequency of wave 2 is equals to 4 times the frequency of wave 1. So let's label this as V1 and F1, and this is your lambda 1 for wave 1. Alright, so wave 2, lambda 2 will be equals to V2 by F2. This is true. But now they are saying that F2 is equals to 4 times F1. So in place of this, write 4 times F1. And they're also saying something regarding velocity, that it is traveling at a velocity of 2v. So it is traveling at 2 times the first wave's velocity, right? So you get lambda 2 as 2 over 4 v1 by f1, which is lambda 2 is equals to 1 by 2 into v1 by f1. And you know that v1 by f1 is lambda 1 only. So 1 by 2 into lambda 1. See, v1 by f1 is lambda 1 only, no? So the new lambda is half of the initial lambda, right? Or you can say it is v by 2f, just like we have written here, v by 2f. The answer should be D. What I have done is I have written it v1 by f1 and the new is v2 by f2, but write it in terms of v1 and f1 because they have mentioned it is 4 times the frequency and traveling at twice the velocity. So it will directly become half. You can apply direct ratios, but in case you're not able to apply ratio, do it using this method. Alright, and even if you still have doubts in this, feel free to let me know in the comments section. Now, next question. Straight wavefronts on the surface of a ripple tank. Alright, the diagram shows how wavefronts. We know that this is diffraction. What is the name of this effect? So they're just asking the name. The name is diffraction. Light travels from air into glass. What is the relationship between refractive index of glass? We know that refractive index of glass is equals to sin I by sin R. So answer should be C. Which diagram shows the image correctly formed by reflection? Now, in reflection, we know that the distance between the object and the image should be same, right? In this case, the distance itself is not same. From the head and this, it's not same. Answer is clearly D because the distance and the orientation is also the same, right? Now, a student passes parallel rays of light through 4 different converging lenses. He measures the distance x and distance y for each experiment. Now, see, the light rays after refraction are converging at this point. So, this is clearly the principal focus. Which lens has the longest focal length? And the focal length is from the center to the principal focus. So the one having the largest value of y should be the answer. Very simple question. Answer is B. Question 22. The frequency of the microwaves used in microwave oven is this much. What is the wavelength of these microwaves? See, V is equals to F lambda, the formula we are going to use. And since microwaves fall under EM waves, the speed will be taken as 3 times 10 to the power 8 meters per second. Frequency will be 2400 times 10 to the power 6. Capital M is mega, which is 10 to the power 6. And then times lambda. When you solve this, you will just have to transpose this here. 3 times 10 to the power 8 divided by 2400 into 10 to the power 6. When you solve this, your answer will come out to be 0.125 meters. Which row gives typical values for the speed of sound in solid and gas? And solid, we know that it is nearly 5000, more or less depending upon the density. But the average is that. Now, in this case, they're using very small values, but you can easily differentiate. In solid, it will be clearly more. In solid, it will be clearly larger. And in the gas, it will be slow. It will be less. So 3000 and 300, this is the best representation. In gas and air, it is nearly 340. So you can pick 300, that is correct. A hard magnetic material can be used to make a permanent magnet, correct? Which is steel. Steel is used for permanent magnets, right? A soft magnetic material can be used to make a temporary magnet, right? That is iron. Which row shows whether iron and steel are hard or magnetic soft materials? Iron is soft, steel is hard. Answer should be C. A power source is connected to a resistor XY. In which directions are the conventional currents? See, conventional current flows from positive to negative. So it is going from Y to X, Y to X, Y to X. And electron flow is opposite. Electron flows from negative to positive. So electron flow is like this, X to Y. So Y to X in conventional current and X to Y in electron flow. So the answer should be C. 25, answer is C. Question 26, which unit is used to measure electromotive force? The unit is volts only, so the answer should be C. The graph shows the current voltage relationship for a filament lamp. Which statement describes how the resistance of lamp changes as the voltage increases? See, how the resistance of lamp changes as the voltage increases. See, you can clearly see here that initially there is a direct relationship that V is directly proportional to I, right? But soon, slowly, you are seeing that it is deviating away from Y axis. It is going away from current. It means resistance must be increasing, right? The resistance must be increasing because it is going away from Y axis, which is current. It is deviating away from current, so the answer should be C. In the diagram, rod R is suspended from insulating thread, all right. When the positively charged rod Q is brought close to rod R moves away from rod Q. See, if it is moving away, it must be positive here, right? Which conclusion can be made from this observation? Rod R is charged, true, and it is positive. It is possible. If it is repelling, it should be positive. So it must be positively charged, right? Answer should be B. It is possible. They are saying it is not possible to identify the charge. It is possible. If it is getting repelled, it is positive charge. Now, question number 29. The circuit diagram shows a circuit used to run a DC motor from an AC supply. So the input is AC, and we know that the if input is AC, positive cycle, negative cycle, the AC graph looks like this, right? This is a general AC graph. Then they're asking which graph shows the current in the motor. Now, let's do one thing. Let's assume two cycles. First of all, let's assume this is positive here, this is negative here. So the current will go like this. It can pass straight through and it will go like this. Then down. Let's mark the arrows as well. Then it can directly complete the cycle like this. All right. Then there is another option. There is also one alternative way. The alternative way is that current goes like this, like this, like this, like this, like this, and like this. Now it doesn't really create any difference because the current through the motor is going in one fixed direction only. That is downwards. Downwards is fixed. Now let's assume the opposite cycle. The second cycle where the positive is downwards and the negative is upwards. So now positive here, negative here. So the current goes like this, like this, like this. Can it pass through here? No, because the diode is in the opposite direction. But it will go like this upwards, like this, like this, like this, like this. And you notice one interesting thing here that still the current is passing downwards in the motor only. Even when you have switched the cycle, then still the current is passing in the same direction through the motor. Then it will go like this, like this, like this, like this, like this. This is not that wires are connected to each other. It's just one wire is on top of each other. So it will current will pass through like this. So we are noticing even though you're changing the cycles, the current through the motor is flowing in one direction only. The current through motor is flowing. My handwriting is horrible. in one direction only. But I think you get this point, that even if you change different cycles, the current through motor is passing downwards only in both ways, right? So this tells us one point, that the answer cannot be A, because this is an AC graph and the current through motor is not varying. It's not like that in the first cycle it is downwards and the second cycle it is upwards. It's not like that. So A is wrong. Now, option C is wrong. Why? Because even though current is flowing in the same direction, that is right. See, this is your first cycle and this is the second cycle. In the second cycle, the current is flowing in the same direction. It is going downwards. But option C is saying the first cycle is fine, but in the second cycle, current is zero. Is it zero? No. It's just flowing in the same direction. It doesn't mean it is zero. Alright. And option B, it's a DC graph which doesn't have any relation here, because current through the motor is passing and it is increasing, decreasing. So B is also wrong. That is why the answer correct should be D. And why is it not in the negative direction? Because the current passing through the motor, even if you change the terminals, different cycles you take, still the current passing through the motor is downwards only. So that is why option D is the correct one. All right. Question number 30. It's a good question. The circuit shown can be completed by inserting X and Y components, and it can be anything out of LDR, resistor, thermistor. The completed circuit is a potential divider. Potential divider circuit, so we know that this is a series circuit. And in series circuit, current is constant, right? In which the potential difference across component Y. So here the potential difference increases if the temperature increases. All right. Now, one thing that we should point out here, that in LDR or in thermistor, first of all, they're talking about temperature here. So we cannot talk about LDR. LDR depends upon light intensity. So in thermistor, if temperature increases, the resistance decreases, right? This is a point that you should keep in mind. In thermistor, if temperature increases, the resistance decreases. All right. Now let's try to solve the question. They're saying that the potential difference across component Y increases when the temperature increases. All right. Now just think about it. If potential difference is here increasing, the potential difference across component X must decrease. First point, the potential difference here must decrease. Now, if you apply Ohm's law, V is equals to IR, you know that I is constant. V directly proportional to R. V directly proportional to R. You are saying V is decreasing, so R must also decrease. So let me write down here, R must also decrease. Now, just think about it. We mentioned that thermistor will be that component wherever temperature is increasing, but as a result, resistance will decrease here. And where can you see that resistance is decreasing? In component X, you can see that resistance is decreasing. So component X must be thermistor. X must be a thermistor. Answer is D. Alright. If you want me to explain again, I will. Just listen to me carefully. I am explaining this again. See, for thermistor, we know one very basic logic. And let's change the color of the pen here first. Hmm. So for thermistor, you know very basic logic that if temperature increases, resistance decreases. If temperature decreases, resistance increases. This is what you need to keep in mind for thermistor. All right. Now let's try to solve the question. They're saying that potential difference across component Y increases. So the potential difference is increasing here if temperature is increasing, right? Now just think about it. If potential difference is increasing here, you apply Ohm's law, V is equals to IR. I is constant because it's a series circuit, and V is increasing, so R must also increase. So Y is that component where if temperature is increasing, resistance is also increasing. Just think about it. Here, if temperature is increasing, resistance is also increasing. Is it a thermistor? I don't think so. This already tells you the answer, that Y is a resistor, fixed resistor, and X is a thermistor. But if you're still not clear, let's apply the reverse logic as well. If the voltage here is increasing, the voltage here in X must decrease because it's a series circuit and voltage splits in series. So voltage here must decrease. Now V is directly proportional to R. If V is decreasing, R must also decrease. So R is decreasing here, right? Now read the question again. They are saying that temperature is increasing. If temperature is increasing and the resistance is decreasing here, so now you can also see the inverse relation is there. And inverse relation is in which one? It is in thermistor only. So this again tells you that X is thermistor, Y is resistor. I hope this is clear. Now, this question is regarding Lenz's law. A piece of soft iron X and Y has a coil wound around it. The north pole is pulled away from end X, which causes an induced current. See, if north pole is pulled away, then according to Lenz's law, this X will form a south pole here, north pole here. If you try to go away from the solenoid will try to pull you. If you try to enter inside, solenoid will try to repel you, resist you. So south pole will be here. Now what they're saying is the magnet is now turned round so that the north pole is on the left. So now it is turned round, north pole is here, south pole is here. It is taken to the other side of the soft iron, so it is taken here now, and the north pole is pushed towards NY. Now you are entering it inside. So as I mentioned, if you try to enter, the solenoid will try to repel you. Now if north pole is trying to enter, here north pole will originate, which is same. Earlier it was also north pole here. So first of all, repulsion will be there. Attraction, it is mentioned in option A and C. So option A and C is automatically wrong. And since we mentioned repulsion should be there, repulsion is mentioned in both option B and D. So how do we differentiate? We differentiate on the direction of current. See, initially as well, south pole was here, north pole was towards the right in the solenoid. And now also the direction of poles, the alignment of poles in the solenoid is the same. So the direction of current is also the same. There is no requirement to apply the right hand grip rule here. It's a very simple question. If the alignment of the poles in the solenoid changes, then the current changes. But it was same earlier. It was south pole towards the left, and currently also south pole towards the left. So there is no change, same direction. Answer is D. Question number 32. This is a question that will be done using Fleming's left-hand rule. So for that, I have also pasted a photo for you here. See, Fleming's left-hand rule simply tells you that the thumbs point in the direction of force, or you can say motion, and the index finger is the magnetic field, middle finger is the current, and they should be perpendicular to each other. All right. The current in the wire repeatedly changes between a constant value in one direction and a constant value in the opposite direction as shown in the magnet. What is the effect on the wire? All right. What is the effect on the wire? See, if current is constantly changing, you can say current is constantly going up and down. Current is constantly going up and down. Now just think about it. Initially the current is downwards, right? So magnetic field is towards the right and current is downwards, so your middle finger should be pointing down. From this you will notice that the thumb is coming out of the screen. The thumb is coming out of the screen, right? But if your magnetic field finger, that is the index finger, is towards the right and now the current is upwards, so your middle finger should be pointing upwards, then you will notice that the thumb is going into the plane. First it is out of the plane, then it is into the plane. So what is changing? Only the force is changing. Right? Only the force is changing. Answer should be A. I will repeat again. The direction of magnetic field is constant. Current, first it is down, then the thumb will be out of the plane. Then it is in, the current is upwards, then it will be into the plane, the force. Just give it a try, you will get the idea. So the force alternates. A transformer has number of primary turns, the voltage, all right. What is the relationship? We know that number of primary turns over number of secondary turns is equals to voltage of primary by voltage of secondary, right? Is there a relation given like this? Voltage of primary by voltage of secondary is equals to number of turns in primary divided by number of turns in secondary. Answer B is correct. A magnesium ion has double positive charge and chloride ion has single negative charge. Which statement is correct? See, double positive charge means it has lost two electrons, and single negative charge means it has gained one electron. Those students who do not have chemistry, just understand negative charge represents excess electrons. This is just a simple way for you to remember. Negative charge remembers excess electrons. So if there is F negative 1, it means 1 electron extra. It has gained 1 electron. And positive charge represents deficiency of electrons. If magnesium is with a charge of plus 2, it means lost 2 electrons. Alright, a chlorine atom gains an electron to form the chloride ion. This is correct. Chlorine atom loses a proton. No. Magnesium atom loses an electron to form magnesium ion. No. It has double positive charge, so it should lose 2 electrons. Magnesium atom gains. No. Magnesium atom loses. Answer is clearly A. Now, 35. Which row correctly describes an example of radioactive decay? Radioactive decay happens because the nucleus is unstable. So option A is already wrong. Now, unstable, unstable, unstable. Alpha decay. In alpha decay, change of element is there. This is true. In alpha, the element changes because helium particle, 2 protons and 4 neutron, sorry, 4 mass number is released. So 2 protons and 2 neutrons are released. In alpha particle, there is no change of element. No, this is wrong. There is change of element. In beta decay also, the proton number increases by 1. So C and D are wrong. Answer B is correct. Now, question number 36. It's a good question. Listen to me carefully for this. See, a radioactive isotope of sodium has a half-life 15 hours. The table gives data from an experiment to show how the rate of decay of the isotope varies with time. The background count rate has not been subtracted from this data. What is the background count rate? Now, just think about it. Initially, when you're starting, it is 400, right? Now, this question we can do using hit and trial. All right, that will be the simplest and the least maths requiring method. So we will use that one. Hit and trial, we will subtract the background radiation. 400 minus 12. See, this 400 contains the radioactive decay plus the background radiation, right? So the background radiation I'm taking as, in the first case, I'm taking it as 12. So the radioactive decay is 388. Now, if you have 388, let's do it quickly. Let me use the calculator. 388 divided by 2, it is 194, and another half life, 194 divided by 2, it is 97. Then you add the background count again, 12, so plus 12, 109. In the table, they are showing the count rate. Is 109 there? No, the value is off. The value is off. So option A is wrong. Now let's try again. 400 minus 15, which is 385. Now you divide 385 by 2. First half-life, it is 192.5. Then another half-life, divide by 2, it is 96.25. Then you add the background count radiation, which is 15. It is coming out to be 111.25. Is the answer matching? No. 115. Now you must be getting the idea that the answer should be C, and I'll tell you why. Let's solve this one as well. 400 minus 20, it is 380. Now, if you do the first half-life, see, the half-life is 15 hours, so you cannot directly check from 0 to 10 or 0 to 20. You will have to do 3 half-lives because, sorry, 2 half-lives. First 0 to 15, then 15 to 30, so 2 half-lives. So 380 divided by 2, it is 190. Then 190 over 2, it is 95. And now you add 95 plus 20, it is coming out to be 115. So we can say from this that the half-life or the background count radiation is 20 counts per second. Now, those of you thinking that why did we just not divide 400? We cannot because background radiation does not half. there is no half-life to background radiation. There is only half-life to the count rate, right? That is why we had to always subtract the background count radiation and then later on add. You cannot do half continuously. Background radiation doesn't half, it stays constant for these kind of questions. All right, keep this in mind. Now, question number 37. What happens in the process of nuclear fission? See, fusion is when two nuclei fuse together. Fission is when one nuclei splits. So the nucleus of an atom splits. Answer is C. Question 38. The time taken for the Earth to orbit the Sun is approximately this much. The average radius is this much. What is the average orbital speed? See, average orbital speed is 2 pi r by time. 2 into 3.14 into radius is 1.5, and you have to keep it in meters. So 1.5 into 10 to the power 8 kilometer into 10 to the power 3, it converts into meters. Time you will have to take in seconds. So 365 days, each day contains 24 hours, each hour contains 60 minutes, each minute contains 60 seconds. When you do the maths here, your answer will come out to be 3 into 10 to the power 4 meters per second. Alright. The sun transfers energy to the earth throughout the EM radiation. What are the two parts of the EM spectrum to which most of the energy belongs? We need to remember this, that most of the energy is in terms of infrared radiation and visible light. Alright. Now, how does the sun produce its energy? We know that sun is a star and it produces its energy mainly by fusion reactions, and it is mainly by fusion of hydrogen. So correct answer should be D. Alright, this was a good paper, and especially there are a few questions like question number 36, question number 32, question number 31, question number 30, and question number 29. And then there is one more question which was on the better side. Mm, this question number 4. These were the good questions of this paper. In case you have doubts in these questions, feel free to let me know on the comment section. I would recommend that you play the video again, watch it again if you do not understand it. But if the problem still is there, then feel free to let me know.